Hello beginners, this diagram here is a demonstration of how electrical installation, the wiring process is done. What you will find difficult as a beginner is the wiring. So the laying of the pipes inside the walls, the box 6, and the fitting of the lightning points and the sockets are very easy for you. Even someone who is not an electrician can learn that in one day. But where you will find it difficult is the wiring process. As you can see, this is a representation of a distribution board. This is a 3-phase distribution board, and this here is a copper rail. An original distribution board must have copper rails. Some distribution boards have aluminum rails. This long line with a lot of screws for connection of all the neutrals. It must be copper for it to be original distribution board, because original distribution board uses copper rails. So how you can know if it's copper or not? Because some manufacturers uses copper to coat the rail. So you use something like a knife, a small knife. You try to scratch this rail. You try to scratch the rail. So if it's not original, when you scratch, you see that the color on the surface do not match the color you see inside. Then to find out if it's iron, you can also use a magnet. Sometimes when you place a magnet on this rail, it will magnetize it. That shows that it is iron, not copper, because copper cannot be magnetized. This is long iron rail to connect all the neutrals, and this one is also long copper rail to connect all the earth wires. These red boxes represent the circuit breakers. As you can see, this is 5 amps, this is 30 amps, this is 30 amps, this is 20 amps. This 5 amps is for the lightning point. As you can see, this is a 1-gang switch, and these 2 lightning bulbs are connected together. As you can see, the red wire, the live wire are looped together. The neutral is connected together. As you can see, the neutral from the lightning points comes directly to the neutral rail. But here the live wire comes from the circuit breaker to the switch, and this point and this point are not connected, except when you flip the switch they will now be connected. So as you can see, from this point you connect to the lightning points. So in switches, the neutral doesn't come to the lightning points. The neutral doesn't come to the switches, The neutral goes directly from the distribution board to the lightning points. The live wire will always come to the switch first. The live wire comes from the distribution board to the switch. and from the switch you can now connect to the lightning points for one circuit. This is a circuit. When this circuit breaker trips, these lightning points will not be working anymore. If there is if there is a short circuit or a problem, this circuit breaker will trip off. It has a switch, it will trip off, and these lightning points will not be working. For electrical installation, all the wires for the lightning point is 1.5 or 1 mm. 1 millimeter or 1.5 millimeter is used for lightning points. From the circuit breaker, you take the live, you drop it to the common of the switch, and you take from either L1 or L2 to the lightning points to feed the lightning points. If there is a problem here, it will not affect these other circuits. This is why this distribution board is very safe and reliable. It's very convenient for electrical installation. Again, here you see these 4 boxes are four sockets. 4 sockets these sockets for your where you plug your appliances, your electric iron, your electronics, your television, and all that. This is 13 amps. These are the 4 of them are 13 amp sockets. As you can see, all the 8 are looped together, all the neutrals are connected together, and all the live are connected together. And from one of them you take to the circuit breaker. This circuit breaker is 20 amp circuit breaker. You can use 20 amps, 25 amps for the sockets. You can, even if you want, you can use 30 amps. The higher the amperage capacity, the safer. But if you are using 30 amps for socket, it's a waste of money, because it's more expensive than 20 amps or 25 amps. But instead of you cannot use 5 amps here, because if you use 5 amps circuit breaker for 20, where you're supposed to use 20 amps, what it will do is it draws current. So the appliances that you plug here, for instance, if you plug electric iron or something that draws a lot of current, it forces the 5 amps circuit breaker to draw a lot of current. Therefore, it will get heated and melt. It can cause fire, it can cause a short circuit, it causes disaster. You have to be very careful when doing electrical installation. As you can see, this is called a ring circuit, and in electrical installation, 4 sockets, a maximum of 4 sockets, maximum 4 sockets are connected together. 1, 2, 3, 4 are connected together. Don't connect more than 4 sockets, or you are going to be overloading the circuit. This is one separate circuit. As you can see, the live wires join together, all the S join together, all the neutrals join together, and from one point it goes to the neutral rail, where all the neutral, both from the AC or from the water heater or from the lightning point, all the neutrals are coming to this one rail. What you are separating is only the live wires. All the earths are coming to this earth rail. As you can see, the wire, these wires is 2.5 mm each. 2.5 mm. For the sockets, you are going to use 2.5 mm wires. 2.5 mm wires is the suitable wire rating for sockets, and 4 sockets are connected together making one circuit. As you can see, the live wire is connected to this 20 amps socket. All these form one circuit. As you come over here, you see this is AC switch. This is rated 20 amps, but from 15 amps is okay. This AC switch, as you can see, the live wire goes direct on its own to a 30 amps circuit breaker. Then its neutral comes to the same place that the neutral of the socket comes to. Then the earth still goes to the earth rail. This is having this one socket, 115 amp socket for AC is having its own only one circuit breaker for one AC. One AC must have one circuit. So if anything goes wrong with these 30 amp circuit breakers, others will be working. This is because AC has more power than the things that you plug into these sockets. AC consumes a lot of power. That is why you use one circuit breaker from the distribution board to power one AC. This is a water heater switch. As you can see, these are two. It has 4 points and 1 point for the earth. So it also, every one water heater will also have one circuit. As you can see, this is a 30 amps circuit breaker. It is suitable for powering water heater. As you can see, the live comes here, the neutral goes to the neutral rail, and the earth goes down to the earth rail. These 2 points, those 2 remaining points are going to go to the water heater. The neutral will go to the neutral of the water heater. The live will go to the live of the water heater. And the earth will also go to the earth of the water heater. As you can see from this distribution board, this rail, you connect a wire from this rail. You can use 6 mm, 10 mm, depending on the one that you can afford, and you use it to connect from the earth rail down to the ground. So we are going to talk about grounding, why it's important to ground a distribution board in the next video. But this is a demonstration of how the installation, the wiring is done. As you can see, the lightning points, it has its own circuit. This lightning point, these 2 points has their own one circuit. This water heater switch has one circuit. This AC switch has one circuit. These 4 sockets are all using one circuit. I hope this video makes you understand how electrical installation is done. Electrical installation is easy, but in your imagination, if you understand it and if you can imagine it, you can do whatever you like. You can manipulate the installations because you have a good understanding of how it is done. Subscribe to this channel and you will always get update on how electrical installation is done.